All right, so in this video, I'm going to show you the simplest possible beginner example so that you can get started with coroutines and use them in your Android projects. I know that they're a very new thing, so a lot of people don't know what they're about, how to use them, anything like that. So this is going to focus on beginner, 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 complete beginners. You know absolutely nothing, and I'm going to show you how to get started and actually show you a practical example of how you can use coroutines. So typically, when you're using coroutines, you need to do work on a background thread. That's what it's all about. That's what RxJava does. That's what executors do. Async task, although you shouldn't use async task, it sucks. But coroutines are essentially the same thing. It's another option for threading on Android. So the most practical common use case for when you need to use a background thread is number one, if you're making a request to the network, so using something like retrofit or volley, you need to do that on a background thread because you don't want to block the main thread. The second, probably most common, is accessing the internal SQLite database on the phone. So that means using the room persistence library, or if you use the old-fashioned way, which I don't recommend doing with the old SQL database builder thing or open helper, don't use that. Use room persistence library. But anyway, those are the two kind of most common cases when you're going to need to use background threads on Android. Network requests and internal requests to the database on the phone. So what we're going to be doing in this example, I'm going to show you a very simple beginner example. We're going to kind of use a coroutine to simulate a network request or a room request, something that would block the main thread. We're going to get a result, and then we're going to take that result and send it to the main thread where it can be displayed. So getting a result from a background thread and then taking that result and displaying it on the main thread. Very practical. You're going to see a very simple example so that you can get started with coroutines. Let's get started. One more thing before we start, I wanted to mention that I'm going to be showing you how to solve another very common problem that comes up in Android development, and coroutines make it very simple to handle. Imagine the scenario when you need to make a request to a network or to room persistence library, whatever. You need to make a request, you need to get a result for that request. Then once you have that result, you need to make another request and maybe another one. It's this sequential nature of making requests. You need a result. Once you have that result, you need to make another request using that result. Once you have that result, you need to make another request using that result, and so on and so on. Doing this with typical methods like RxJava, live data, executors, this is very tricky. You have to have lots of callbacks. It gets messy, basically. There's not like an ideal way to do it. With coroutines, it's so simple. It is so simple. I absolutely love it. It's so simple. And I'm going to be showing you that in this video also. So make sure to keep watching to the end because that's going to be the best part. Let's get started now. All right, so coroutines for beginners. Step number one, getting the dependencies. This, of course, is the first step. You need the coroutines dependency. You can get it I got it from the Code Lab. You can just like Google Android coroutines code lab, see what I just Googled there. That'll be one of the first links that comes up. You can look at the code on GitHub, or you can go to the actual code lab, go to step number 2, step number 3, and that'll give you the dependencies down there. Or just go to the source code that I have for this project. There's a link in the description of this video, and you can copy the dependencies there. Either way, get the dependencies and get them into your project. By the way, I didn't show you like creating this project, but it's just a blank activity. There's a single activity, a single layout. I'm using Kotlin and I'm using Android X. Nothing fancy here. Just to show you, just because this is a beginner example, all I did was go empty activity, use Android X, and use Kotlin. That's all I did to create this project. So anyway, now the next step is I want to show you what's going on in the activity. So I have just some very basic stuff in our activity. I have a button and a text view. The text view is going to display some text, as you might have guessed, and the button is for firing off that simulated network request that we're going to be doing some background work on. So you can just copy this. It's very simple, a button and a text view. Very straightforward. That's pretty much all the prerequisites you need to get started. Now let's go into main activity and let's take a look at simulating this background request and using coroutines to do so. So the first step here is going to be building a method that returns something asynchronously. So you can imagine a network request or something to the room persistence library. So let's build that. So the first method will be private suspend. This is a Kotlin keyword, a Kotlin coroutine keyword, suspend, which I'm going to explain in just a second here. And I'm going to call this function get result one from API. And you're probably guessing right now, why did I name it result one? Because we're going to have a result two later on. So get result one from API is our first function. And so what is a suspend keyword? Well, suspend when you're dealing with coroutines, will mark this function as something that can be asynchronous. So it doesn't necessarily mean that it's going to be on a background thread or on the main thread. It just means that it's going to be able to be used in a coroutine. And just to kind of give you an example, I'm going to pull up another project that I've been working on. So here is a DAO class for the room persistence library. Notice all of these methods are suspend functions. If I remove this, they can't be used in coroutines. So if they have suspend, the suspend keyword, it means that they can be called from within a coroutine. And the same goes for retrofit. Retrofit requests are identical. You just mark them with the suspend keyword, and then they can be called in a coroutine and therefore executed on a background thread. All right, so now let's build this method. So first, I want to log the thread that this gets called on. So I'm going to write one more method, private fun log thread. This is going to be the method name, and it's going to be a string. And I just want to print line and debug just to give me something to filter on. I'm going to print the method name and then the thread. So colon, and we're going to do $, and in here do thread.currentThread.name. So you can see what method's being called and what coroutine or thread it's being executed on. And actually, before I carry on, because I've used a couple kind of confusing statements in the last minute here, I need to clear this up before we move forward. So you might be a little confused about what I just said there. I kind of used the word coroutine and thread interchangeably, but actually coroutines are not threads. They're like threads, but they are not threads. I think the best way to think of them is like if you think of a coroutine as a job that needs to be done and the thread as the place where the jobs get done. But keep in mind that any number of coroutines, many coroutines can be operating at the same time inside a single thread. So it's not a thread. Many coroutines can exist inside of a thread and be executing, whereas there can only be one thread to host all of those coroutines. Well, technically you could have more threads, but it would be like a totally different category. So you can have any number of coroutines doing some work inside a single thread, and they can be executing all at the same time. So just kind of keep that in mind as we move forward. All right, so let's go into our get result method here, and we're going to log the thread that we're working on, and I'm going to pass the method name right here. So there's the method name getting passed to our method, and that's going to print out what coroutine and what thread is currently the work is being done on. Next, I'm going to write a function called delay. This is a coroutines thing. Now you might be thinking, oh, this looks kind of similar to thread.sleep, which is how we always did it in the past. But these two are very different things. As I just mentioned, coroutines are different than threads. They aren't threads. There can be many coroutines operating within a single thread. So that's what this delay will do. This delay will only delay this single coroutine. It will not delay the thread itself. But by calling thread.sleep, you will sleep the entire thread. If there's many coroutines working in that thread, all of them will go to sleep. So there's a big difference here. This is like delaying a single coroutine. It will not interfere with any of the other coroutines that are operating on that thread, whereas thread.sleep will sleep the entire thread, and all the coroutines inside will be disabled, basically. You never want to call thread.sleep inside of a coroutine. Now that we want to, this is going to be simulating the delay for making the request to either room or the network. We're just delaying it for 1 second, and then we're going to return a result. And this is going to be result number 1. Actually, I could make this into a constant, and I need to actually return a string from this. So let's go up to the top here and just do private val. We'll do result 1, and that's going to equal result 1, and pass this right here. Okay, so now how do we execute this suspend function and get a result? Well, right away you might be thinking, well, I'll just do value result 1. Actually, I'll make a method for it. So let's make one more method. We'll do private function fake API request is what we'll call the method. And inside here, I'll do val result equals, or go result1 equals get result from API. And then I'm going to come back up into this button click, and I'm going to call fake API request. So what's happening here? It's giving me a warning. It says a suspend function get result 1 from API should be called only from a coroutine or another suspend function. So it's basically telling me that I'm missing a step. I'm trying to call this asynchronous coroutine function, it's marked by this suspend keyword, inside something that is not marked with a suspend keyword, and it's also not inside of a coroutine. So there's a few ways you can fix this. You probably already thought of this, add suspend to this method, but then you basically just propagate the error back up to this method and you have the same issue. So what we have to do is we have to launch a coroutine, because right now we have no coroutines, we just have a suspend function. So we need to actually do that and launch our first coroutine. So I'm going to come up into the button click here, and we're going to do that. Oh, and we can mark this as suspend. So I'll mark this as a suspend function. The error is going to go up here, and now we are going to launch a coroutine inside of this button click. Now there's a couple ways you can do this. With coroutines, there's this thing called scoping, this kind of property called scoping, coroutine scopes. And what a coroutine scope is a way to organize coroutines into groupings. As I said before, coroutines are like jobs. So a coroutine scope or a coroutine context is like grouping a bunch of jobs together. So if you had to execute job 1 through 5, so job 1, 2, 3, 4, 5, and suddenly it failed on like job 3, you would cancel all of the coroutines within that scope, and they would all cancel. So it's a way to group them together so that if one fails, then you can cancel them all. If a result changes, you can do things. You have options. And I'll actually pull up the coroutine documentation, and we can read what they say about coroutine scopes. So it says it defines a scope for new coroutines. Every coroutine builder is an extension on coroutine scope and inherits its coroutine context to automatically propagate both context elements and cancellation. So it's a way to group jobs together, or coroutines, into a similar categories so that you can take action on many of them at once. That's kind of how I like to think of them. So let's stop talking, because you could probably talk about coroutine scopes for a long time and look at a lot of different examples. So I'm trying to keep this simple so that you can see something in action that you can use right away. So the first kind of scope, probably the most common scope that you'll end up using, is coroutine scope, and here inside of this bracket you want to specify the coroutine context. The two options that you'll find yourself using are either IO, so just the letters IO. If I import that means input output, so that's like going to be your network requests or your request to a local database. There's main, which, as you might guess, is for doing work on the main thread, and there is what is it? There's the last one, default. So default is for doing any heavy computation work. So the three types, I'll just type them up here, is IO, main, and default. Those are the three kind of coroutine scopes that you'll find yourself using all the time. And IO is for network and local database interactions, things like that. Main is obviously for doing stuff on the main thread, so interacting with the UI. And then default, they say to use for heavy computational work. So like if you have to filter a large list and pick things out and arrange it different ways, that's when you want to use default. So we are simulating a network request with this video, with this example. So I'm going to be using the IO option. The next step is calling .launch on this coroutine context. And what this is a coroutine builder. So this is essentially what constructs the coroutine and gets it all ready to go. So now all I need to do is just move this method inside of my coroutine, and I'm ready to go. It tells it what context I want to launch my coroutine in, and then I'm calling .launch to actually create that coroutine and start it up. So that's it. So now this will get called. Let's print this. Let's go print line. I'll go debug and just get that result number 1, and we can run this and take a look. So I'm pressing Shift F10, which is the hotkey to run it on my computer, and I'm going to choose a device and run it. All right, so there we have the app. I'm going to bring up the logcat just so we can see what's going on here. Looks like I got a bunch of old stuff in there. Now I'm going to click it. It says right there, get result from API. There's that thread printing out. So that's the logging thread method printing out right there. And then it says debug and result number 1. It prints result number 1. So everything is working as we expect. So now that we've got a result from our fake API request, what if we wanted to set this result to the text view in activity main? So if you look in activity main, there's a button and a text view. So suppose I wanted to take this result and now set it to a text view. Now you might be tempted to just do text, which is the ID of that text view, do set text and do result number 1. But if you have been around Android development for any amount of time, you will probably know that yes, that will cause your app to crash. It's going to cause your app to crash because we are doing work on a background thread with our fake API request method, and we're trying to interact with the UI by setting that. So I'll just run it and just show you that it does actually crash when I try to do that. So if I click the button, it's going to get the result and it's going to crash. So how can we solve this problem? Well, we need a way to basically send this result to the main thread where it can then be set to the text view. So I'm going to create a method, private fun set new text, I'll call it. It'll take input as a string, and I will do value new text equals text.text dot toString. So I'm getting whatever current text is already on the text view, and then I'm appending the new text. So new line, and I'm going to append the input. So $input. So that will get the text that's already in the text view, get the new input, append it, and then we're going to set it. So text.text equals new text. There we go. So that will set the new text, but still that's not doing it on the main thread. That's just going to do it on whatever thread it gets called from. So that's still going to crash the app. That doesn't solve our problem. So I'm going to create one more function. It's going to be a suspend function. It's going to be called set text on main thread. It's going to take a string as input, and now we want to fire up a new coroutine that will do its work on the main thread instead of doing it on IO or default. So basically we want to make use of this main kind of this coroutine scope up here. So inside here you can do this a couple ways. You can do it the way that we did before by doing coroutine scope and then passing main in here, or you can just write with context, pass main, and then that's it. With context main, and that will fire up a coroutine and get it started for you. So all you need to do is do set new text and then pass that input, and everything will get set correctly. So now let's try to call set text on main thread inside of here. So set text on main thread and pass result 1, and let's see if that gets added to our UI and the app doesn't crash. So I'm pressing Shift F10 to run it, which is a shortcut on my computer, and running the app. All right, there's our application. Let's click it, wait 1 second, and there is result number 1 getting printed to that text view. So everything's working. We're not freezing the UI. You can see I can keep clicking this. We keep getting results. Everything's working as intended. So this is a very simple example, but this is like you do this all the time in Android development. You go and make a request to a network or the room persistence library, you get a result, and then you display that result. So this pattern is going to come up a lot, even though it seems very simple, but that's the point. I mean, coroutines make this very simple to do, and that you're just barely scratching the surface with what they are able to do. Like this is a very simple example, and I plan on making more videos with more examples and showing you what they really can do, the other things that they can do. Now, I'm sure you're wondering, what is this with context thing? Because I didn't really explain that. I just kind of used it and showed you that it was able to switch the context of the coroutine, and we were able to do that work on the main thread or set the text on the main thread. If you call with context within a coroutine, it will switch the context of the coroutine to whatever you mention. So this is another property of coroutines. They're thread independent, I guess I could say. You could start a coroutine in one thread, pass it to another thread to do some other work, pass it to another thread to do some other work. It doesn't matter. The coroutine can be started in one thread, do its work in another thread, do some more work in another thread, and then return to the main thread. And all you have to do is change the context. And there's other ways you can do this too with different method calls, but the simplest way is to just call with context, and it will take wherever that coroutine was doing its work, and it will move it to the thread that you specify. In this case, it's main, and then it will do whatever you like. So that's another thing about coroutine, and it's another possible optimization you can make. You can try to reuse coroutines whenever possible and not keep firing up new ones. So launch will build a new one, and then you can just use with context to switch the context of that coroutine and change where it's doing its work. So that's yeah, that's all I want to do for this example. Now we're going to go into a little bit of a more complicated example, or not really more complicated, but I want to show you something else that's really cool that they can do. And I mentioned this at the beginning of this video. So a very common thing you run into is you want to make a request, you want to get a result, and then you want to use that result to make another request. I'm going to show you how simple that is with coroutines. So let's scroll down to the bottom, and I'm going to create a second method here for getting a second result. So private suspend function get result2 from API, and this is going to return a string again. Once again, I want to log the thread. I'm going to pass the method name inside of here. And we're doing almost the exact same thing. This is going to be another delay of 1 second, and I want to return result 2 this time. And I'm going to create that property. I thought I clicked create anyway. Well, let's just copy this. This is going to be result 2. This will be result 2. And now we're going to retrieve that result after we get result number 1. So I'm coming into our fake API request method. And after I set the text on the main thread for result number 1, I'm going to retrieve result 2. So value result 2 equals get result 2 from API. And I want to set text on the main thread, pass result number 2, and that should be it. So by default, when you call suspend functions in this way within the same job, they wait for completion. So like result number 1 here, it's going to wait until it gets that result. Then it's going to continue. It'll set the result. It will get the second result, and then it will set that on the main thread. So now let's run that and see what that looks like. Open up the log, get the app out here. Let's click it. 1 second, you get result number 1. The next second, you get result number 2. So you can just imagine, if for whatever reason you actually needed to pass, result into here. We'll say that this requires result number 1, and then you had to do something with it. You could just take result number 1, pass it to the method, and then make your request. So by default, it does this when the suspend functions are called within the same coroutine. This one waits. It'll continue, do its stuff. The next one will execute, do its stuff, and then get that result. There's a lot of different ways you can do this. Like I said, I'm just barely kind of scratching the surface on what coroutines can do. I plan on making a bunch of new videos, but hopefully this helped and you saw some cool examples of how you can make your first coroutine, how you can, fire it up on a background thread, how you can then pass some results to the main thread and display it. So let me know if you liked the video. Let me know if you want to see more, because there's so much you can do with coroutines, and I plan on using them in my newest upcoming project that I've been working on. So let me know, and thanks for watching.